So the afternoon is trundling on really well, and we have our next talk, which is going to be Steve, who's going to talk about Naturebytes. Just want to flag up, we've got our two kind of finishing off acts later, which is going to be Neil and then Ada, both, well, actually, and Steve as well. They're all going to be fantastic. It's all been a brilliant day today. So I'm going to get out, and I'm going to operate the laptop, and Steve's going to get some nature.
Okay, am I on? Can everyone hear me okay? Yes, great. Okay, hi everyone. My name's Steve. I'm from Naturebytes. So as a conservation ecologist, what I do is I use technology to try and better understand animal behavior and ecology so we can use that information to help protect them and manage our environment in better ways. So it benefits the wildlife and it benefits people. And a large part of my job is using new tools in different ways. And as co-founder of Naturebytes, we've used the Raspberry Pi in some of our technology because it's made computers a lot more accessible, more affordable, and allows us to use different sensors to collect data on a scale that wasn't quite possible before in our conservation, very tight, low budgets. So I'm going to give you a little whip through of some of the conservation projects that I or my colleagues are involved in that are active at the moment, because there's too many projects to go through that involve the Raspberry Pi and in wildlife. But I'm giving some very specific examples where the Raspberry Pi technology is being used in conservation in the field and is having real benefits and outcomes. So technology is really important for us. Back in the day, conservation ecologists used to go and sit in the wilderness for hours and weeks and months and years on end to try and collect information on animals. But now we've got amazing technology on huge scales. So as you can see on the top left, that's satellite imagery. So that allows us to see changes in the environment on a scale that would otherwise be impossible. So on the top left, you can see the Amazon rainforest, then 30 years later, getting cleared out, so all that gray space. We wouldn't be able to get that sense of perspective without those satellite images, which are really valuable. And the technology goes right down to the molecular level. So on the top right, you can see a water sample, and using eDNA, that's forensic biology. So using small molecules and skin cells and waste from that water sample, we can tell whether there has been hundreds of animals in that small water body or in the sea. So it's really a fantastic development in technology. And then we'd like to put sensors on lots of things. So instead of having to go and sit out in the wilderness for months on end, now we can put sensors on things. So we put sensors on planes, so you can understand the landscape, through to having all those sensors in your hands of everybody on your mobile phone, taking photos of wildlife, understanding distribution. Which species are there, which are not, and then that's really useful information. So a theme of this talk will also be citizen science, so it's really inclusive, so showing you how everybody can get involved in science using these technologies, and it's not just the experts or the scientists. We all want you to help out too. So here's an example of one of the tools that's used most widely by ecologists. This is a camera trap. So this is a camera you put out in the wild. You can leave it there for a year. Rather than having to sit there for ages, waiting for something to come along and take a picture of it, you can put it out there. And that's a snow leopard out in the Himalayas. So that camera will get left there for a year. And then you can go and pick it up, and you start to understand where these really elusive creatures are. Because if you went up there, that animal would avoid you. So really useful tool. And this is where it started off. This is actually the first camera trap. And you can see there's a thin wire just on the top there. And that was baited, and a deer would come along, take a bite of it, and then that would cause the camera to be triggered, take a photo. And this is back at the beginning when these technologies were just being developed. And now, as Naturebytes, this is a wildlife camera trap powered by the Raspberry Pi. So this is out in Kenya, taking pictures around water holes to understand what animals are out in Africa. And we've got some out in the Amazon, and we've got them out on tropical islands. We've also got them out in schools. So schools are getting involved in seeing what's going on in their back garden or in their park. And this is how it works. So you can see basically here, it's very simple, and anyone can build these. So you've got, on the top right, you can see the Raspberry Pi camera. And then at the bottom, there's a PIR sensor, and that detects body heat. So any bird or mammal that goes past your camera, it will tell your Raspberry Pi to take and save a picture, and that's really useful. So you get to see animal behavior you wouldn't see if you were there, and it's a non-invasive way, so we don't interrupt or disturb the animals. Does anyone know what this is? Does anyone want to shout out? Hedgehog. Hedgehog, that's right. Okay, that's great. So we've been using these camera traps to help these guys. So a project with the Wildlife Trust, and hedgehogs, they're actually in trouble. So over the past few decades, unfortunately, the populations have decreased by 50%. So these guys are in real trouble. And that's an indicator of how healthy our environment is. They're actually the UK's most popular and favourite animal. So if we're not able to look after these guys, I don't think it reflects good on us, good on people like ourselves at all. But there's still hope, and we can get a better understanding of where these animals are so we can help them. So they like to live in hedgerows, they like to eat small insects in bushes, but unfortunately their habitat's been destroyed, and lots of fields are using pesticides. So that kills off the insects which these guys need to survive. But some of you might be lucky enough to have these in your back garden. So if you do have them and you're lucky enough, look after them. You can build them a hedgehog home. You can help build some scrub, keep some wild areas in your garden so that the insects thrive, and you can help out these guys. So we've been working with the Wildlife Trust. This is a citizen science project, so this is members of the public, again, working with the conservation scientists. And this is basically a very low-tech tool that conservationists use. You can see on the top left, that's a hedgehog tunnel. So that's basically a bit of card, bit of paper, some ink, and some bait. So the hedgehogs come in, they smell the food, they walk in the ink, and then you can identify that they've been there the next day when they've come out by their footprints. You can see their footprints on the right. So it's a really useful tool, but also we've been using our camera night vision technology in partnership with the Wildlife Trust, and to better understand where the hedgehogs are. And this project's running in London. And unfortunately, we've only got one known population of hedgehogs in London. It's in Regent's Park, if that means anything to anyone. So just a small population. So it's very sad that in this urban environment, our most popular animal has almost completely disappeared. But we don't actually know that for sure. So we've been putting out these tunnels and the camera traps so we can understand where they are, where they're not, and how successful they're breeding. So what we did is we've got a video here from one of our camera traps that we tried. And luckily, we were fortunate enough to see in the night just one of these guys in London wandering around in one of the gardens. And that's an area where we didn't know the hedgehogs were before. So that's really useful information for us to understand how healthy they are, and that will help protect them. Also in London, we've got with the night vision camera traps were put out in a park, and it's a top secret location because we don't want anyone to know where it is because people might go in and disturb it. If we could play that video as well. Oh, sorry, next video. It's the hedgehog again, just so you can revel in its majesty. And then the next video, are we moving along? Is that the next one? Oh, hang on. There we go. So we were fortunate enough to see these guys. This is a badger. So this is the UK's biggest mammal. And in London, badgers have almost completely disappeared. And so we're worried about them dying out completely. So we were really fortunate and really pleased to see that one of the cameras picked up a mother badger with its cub. So this is really useful information so we know that the badgers are there, but we know that they're successfully breeding. So we know that they'll continue to increase and there'll be a healthy, and we hope there'll be a healthy population there. So we can use that information to focus and protect on managing these areas. I can't seem to move. Could you move that just to the next slide, please? Thank you. All right, does anyone know who these guys are? Shout it out if you know. Yes, brilliant, excellent. Does anyone tell if there's another species on there? Okay, well, you did very well. Bonus point for you. But we've got a blue tit on the right and a great tit on the left. And most of you will see these. You think, oh, what's the conservation interest in these? Because you see them every day in your garden. I don't need to look after these. But actually, recently we found that across Europe, insects have completely crashed in numbers, and this is right across the field due to climate change and, again, pesticides in fields, killing off the animals. Very sad. But what we find is these common species, they actually feed on the insects. So if you haven't got any insects, they've got nothing to feed on. They struggle to reproduce and survive, which is a big worry. So we've been running a project with the Natural Science Museum of Brussels. This is in Belgium. And we've been building Raspberry Pi nest boxes. So we've taken the camera technology with the Raspberry Pi and put it in a nest box. So we've got schools building Raspberry Pi camera nest boxes all around the country. And you can see here on the top left, you've got the bottom corner of England. That's Kent there. And then you can see in Belgium where all these nest boxes are. So I think there's about 600, 700 schools there now. All these schools learning digital skills, learning how to use the Raspberry Pi to better understand the animals in their environment and which birds are coming into nests. So they're actually getting their own nest box, putting it up, and seeing which animals come into their local school area. If we could just play that video. Thank you. And this is a clip from one of the schools. And this is just showing the life cycle through the nest box. So you've got the great tit in here. You can tell from its solid black cap. And it's built using lots of twigs and material to build its nest and insulate its nest box. This is the camera looking down from the top of the nest. And there you can see it successfully laid some eggs. I think there's about 9 eggs in that nest box there. And then you just see the mum just moving across out of the picture there to reveal the young chicks. And you can see them now bringing in insects to keep their very demanding chicks happy. You see them growing up. And the schools are recording all this video. They've got a live view in their computer, on their computer in their classroom, so they can see what's going on. They're reporting and blogging back to centrally all these 600 schools back to the Science Museum, where the scientists are using that information to monitor the population of those species. So this is really great. So we've got the young people adopting their own bird family and really getting excited about it, really caring about it, and following it through from the excitement of seeing a bird in your nest box to laying the eggs. Unfortunately, some of them don't survive, but they follow that all the way through to when they fledge, and then they feel sad when the birds have fledged, but they're almost proud parents themselves. So they're looking forward to the next year again when they start coming back in spring. If we could just go to the next one, please. Okay, does anyone know what this is? Yes. Rhino, yes, well done, Rhino. So I heard some of you got it up there too. So this is a black rhino. And this is, unfortunately, in Kenya, is under threat from people. So people use the horns on the rhino for medicine, for building ornaments, and quite often, unfortunately, the numbers are decreasing due to poaching. So they get shot, they take off the horn, and they sell it. So we've been using a Raspberry Pi powered camera. This is a slight step up in the technology. It's a lot more specific. So this has got Raspberry Pi. You can see the camera lens in the middle there, surrounded by LED lights, so that allows us to give some illumination at night. And then also in the top left, you've got the PIR sensor. So again, that just detects the movement of any rhinos or any people that go past. So we can understand where the rhinos are if they're coming into these certain locations. But we also get really useful information where people are coming into the park to try and kill the rhinos. So a photo is taken by the camera of the poachers unawares. Then they send it to the guards, to the rangers, who will get alerted to that, and then they'll come out and catch the poachers. Then they can use the photographic evidence to prove that the individual poachers are there trying to hunt down the rhinos, and then that acts as a deterrent and helps to stop that poaching threat to these rhinos. And there you can see a ranger putting out a camera trap there, and that will monitor numbers of wildlife as well as detecting any movement from poachers. And this guy, does anyone know who this is? Penguin, yes, very good. So this is an Adelie penguin, and this lives in Antarctica. And what they like to feed on fish, and they like to lay eggs on land, on the ice there. But their environment is very fragile. So unfortunately, due to climate change, again, these guys are reducing in their numbers. Overfishing of their food stock is also causing a threat to them. So thanks to the Raspberry Pi, the same camera technology, we've been able to put them out in Antarctica. So this is a project with Oxford University, and it's called Penguin Watch. So the camera you can see on the pole out there, it's a really beautiful remote location, but it's really expensive to get there. It's difficult to get out there. It's really harsh conditions. So instead of sending the ecologist out there, we can put cameras out there and we can monitor the health of the penguin populations. We know how many are there. We can understand the timing and how that might shift with climate change. And that's all really valuable information, a lot of data that we can use to help understand, manage, and protect these species again. And here you can see where it's been put up, the camera attached onto the pole looking down onto the penguin colony. And when you go to one of these remote locations like Antarctica, you're not actually allowed to make any changes to the environment. It's very sensitive, so you don't want to put any man-made materials out there that we don't have to. So securing the cameras and the poles, we'd use, the team would be using rocks to secure it. But when you're taking these rocks up, you've actually got penguins all around you. And these the Adelie penguins, they use pebbles to build their nests. So when we're moving the rocks to secure the camera, we're revealing a whole treasure chest of new amazing pebbles that these penguins have never seen before. So we had, the team had penguins following them around, each picking out these pebbles that were freshly revealed so they could build the best nest in the land. And we had one penguin that followed the team all the way around. By the end of it, he had his choice of all the girlfriends in the whole colony, so he's the most popular guy there. And then from the footage that we get, these cameras are set up to take a picture once every hour or two, and then you get a time lapse like this. And you can see the penguins here moving around. So what we can do with this photo information is that we can identify the species, how many there are, whether there's any chicks and eggs in the area, the timing of these as well, and whether there's any big predation events. So one of the threats are other animals eating the chicks as well. So we get all this really useful information from the images. And what's great about this project, it's called Penguin Watch. They actually put all the photo information out online, so anybody, including you guys, can go online and help identify the species, count how many there are, and that's really, really valuable information, so you can all get involved in the conservation of the penguins in Antarctica too. And is that just going to play out on loop? And so I think there's around 100 cameras out there monitoring different species in Antarctica, so that information is being generated all the time to help the scientists who are back in the UK understanding how this environment is changing and shifting all the way on the South Pole of the Earth. So on to the next species. Does anyone know what this one is? Yes? Green turtle, excellent, got the species as well, fantastic. So this is a green turtle. These are an endangered species too, unfortunately. So they live in the marine environment, and one of the big threats to them is over-harvesting. So again, people eat their eggs and use their body parts and sell them. Another threat is overfishing and pollution. So a big problem for these guys is discarded fishing nets and plastics are toxic to them. So we want to try and understand more about their environment again, so we can help protect these species. So this is a Raspberry Pi camera tag that we put on the back of the turtles. So very simply, there's just a Raspberry Pi, a power management board, a battery, and a camera. And the camera you can see in the top of the picture there. It's put into this tag, and then put on the back of a nesting female green turtle. So these green turtles, they'd come onto the beach about every 10 to 14 days, a few times every breeding season. So we go out there to disturb them as little as possible. So when they're laying their eggs, we have an opportunity to just place the camera on the back of the turtle, so we can then, so the camera is then safely attached. There's no harm to these turtles at all. And then once the cameras go off, this is the information that we get back from the turtle. So this is a cool video from riding on the back of a green turtle, if it loads up. So here you go, you can see popping his head up out of the water. It's a really great shot, and then you see him diving back down. So this gives us information we wouldn't be able to get otherwise. So they're really they're usually solitary animals, but you can see there's a lot of interaction with other turtles there too. So this information is getting collected and analyzed as we speak with Exeter University. You can see them all hanging out, playing together. We've seen them having little green turtle hangouts with 5 or 6 of them, but you can also, which is really interesting behavior, so we can understand what's going on under the water that when we're not there. But we also get information on the level of plastics. We can see the pollution in the water. And there's actually some of the plastics we're able to identify where exactly they came from. So this plastic is getting dumped into the water, fishing nets dumped into the water, and they get carried away in the tide. But thanks to this footage, we're able to see how big a threat that is and where it's coming from. So that's going to help some of the sea turtles too. Could you just move to the next one? Thank you. Okay, cool. So that's the kind of end of the projects that using the Raspberry Pi that I've been working on. Just looking into the future, I know this is another project. I'm not involved in this project at all, but this is the Nemo Pi. So this is essentially a weather station with a Raspberry Pi that goes under the water, so it can detect the conditions of the sea. And why do we want to do that? Because climate change is a huge problem for corals. So by about 2050, nearly all the corals are going to be completely wiped out. And coral reefs are one of the most important habitats under the sea. So people will survive on it. It's really important for coastal populations, but also guys like us, green sea turtles there, really depend on coral reefs. So very small changes in temperature and conditions completely kill off that coral reef. So we want to understand what activity is going on, whether there are too many people diving there, and whether the water is warming. So that helps us protect a number of underwater sea creatures. And this is not a Raspberry Pi camera, but it's a basic underwater system. This is with the University of Western Australia in a British overseas territory in the middle of the Indian Ocean. So this is the kind of creature that we want to protect that rely on coral reefs. And it's a really diverse environment. So by using the Raspberry Pi, we've been able to get technology out there to better understand our world and identify these big gaps and help protect our environment. So I've talked about some of the projects that we've been running, but the Nemo Pi is one that just got Google funding, so they're going to be doing this in the future. And I hope that from some of these examples that I've inspired you a little bit to use your digital skills, use your Raspberry Pi to get outside, understand wildlife, and try and get involved in some of these citizen scientists, because all this information is really valuable to help keep our ecosystems healthy. And that's it. I'll let it play out so you can be transfixed by the wonders of the ocean. But thank you very much, everybody. Cheers.